Hello, let me show you my latest development, my latest program. It's called Vauls. This is like graph where you can add and remove nodes, connect them, and evaluate in parallel. And you can uh, compile and run each node in written in CPP. So you can take any program, any node, and change their code and compile in real time. Yeah, this is my dream how to implement such things. So in Maya, you have uh, nice graphs. You have a lot of nodes, a lot of simple nodes like sin, cosinus. No, maybe sin cosinus, not the example. Maya doesn't have these nodes, but plus minus a, plus minus average, multiply divider, and etc. etc. A lot of simple nodes. But the idea is to have a middle kind of nodes, not so simple like add, but more complicated, like maybe limb or spine or maybe more, maybe other types. But the idea is to have not hundreds of nodes in the graph, but maybe tenth, and you can change the code of each node at the same time. This is the first. I have module written in CPP called PyG. This is the CPP evaluator in using LVM and Clang. So I written in CPP and made a Python model from it. Here I imported initialize LVM, and this in the below. I create graph, create node, build graph, and then run it. Each node conceptually is a data block, and there is some program that attached to this block. So when you create node, you set up some program. This program is compiled from this and registered in some registry. I compile this program to this handle, then register this handle as prog. Then I create node A with this prog attached. Then I build graph and run. And let's see what's happening. Here you see two attributes of double input and output, and here you get input and double output, and you add one to input. Press run, and you see the graph printed. You have node A, input 0 and output 1. So this code is evaluated. Done. The more interesting thing is how to connect several nodes, like create node B of the same program and run connect. I'd like to connect node A output to node B input. So let's see what's happening. My graph has one connection from A output to B input, then B A evaluated, and then B. You see B input is 1. This is A output. And then B output is 2. So the graph is evaluated, and we have here some function called gdump. I used for graph CPP task flow. It's really cool library, and my advice is to use it wherever you find a place to apply it. It's a really cool API, nice documented and allowed. So let's print something. And this is the graph itself, and you can open like graph this and visualize your graph state. So I have node A and node B connected. CPP task flow you can find here. CPP task flow you can find on GitHub. Yeah, it's a cool thing. Yeah, you see you can cluster nodes and etc. Yeah, it's cool. The next thing is to create interface for all this. I almost done it. It's also called Vault. So the first part of the system is Git helper. This is a library that encapsulates all the things that associated with LLVM and Clang, because you need a lot of libraries and a lot of includes for this. And I compiled all this in a single library. Then I created PyGit. It's a graph implementation. It's a PyD file you can import and use it in Python. Currently, it's Python 3.10. And this thing is a Python-based UI interface that uses this approach. And here you can create nodes, edit programs, and etc. Let's start with creation nodes. This is node sign. You have inputs, outputs. Here you can open programs. So some programs were already registered here, and this is my experiments. Let's start with sign. Here you see program and you see program code. This is, I can comment because this is other tests that I'm doing. Currently it's not used. Here you see the same code. I see input, output, and other things. I can duplicate this node and connect. Yeah. And the magic here is you can see the result here. This is CPP nodes. Actually, this one and this one are data blocks, and some program called sign is bind to these data blocks. And I can create some widgets to control the state of the graph. I have, for example, simple widget called double. This is input widget. I can change this, and I see that it evaluates to 0.14. And I also can create output widget. Also with port, you see pink color is double. I can change and you see the result. Also, it's interesting that you can add another type widget called double plot. Set here 10. This is experimental and nice, so you can see what's going on with your function. It's seen sign. Also, you can add some timer. Timer is also input widget, and you can change. It's more interesting, yeah. A timer works, it triggers graph evaluation, and I set some value here, initial value of the graph, and then the graph itself is evaluated, and then output widgets got their values, you see. And the interesting thing here is that all things you can change at the same time in runtime. Yeah, you can see sign, and let's add another type attribute, amp. 0.0 means it's double. We can add as float or maybe a string, whatever you want. You may add some additional types like point, 1, 2, 3, and etc. All types are accepted. Let's see. Let's set it as double. Here input and amp as output and multiply and amp. Compile, and you see updation here. That's cool thing that you can change the code, compile it, and all the programs will be changed as well. It's nice for experimenting, and you can set here and set here. Set here amplitude bit lower and change this to 10. That's cool. I can change amplitude. So graph is evaluations. That's cool. Now I'm working on subgraphs to encapsulate some nodes, so I can create nodes like this. I can connect, and when the node selected, I can duplicate, and all the connects are duplicates as well. I can even use undo operation to cancel what I did. Subgraphs is a thing that should work as an encapsulator of some things like functions in real. So I select this, go add subgraph. It's like dungeon because I like dungeon crawl games. I add like this dungeon and go this. You see where somewhere deeper we go down to reach Vauls here, and we win the game. Here you currently is in product. I'd like to add some entries, input entries, some output entries, and then here you also able to create some another dungeons, another functions like functions. Consider it as a function, yes. And then in the upper graph, you'll be able to create the subgraphs, and this is a single node. You can with all outputs defined in this thing, and you can create a lot of such things. Yeah. Let's show me some nice example. It's a snake game. Add some widgets. This is the type of vector int connect, and this is a widget that accepts shortcuts and generates key was pressed, and in the code I control what key is pressed and what to do. The interesting thing about this graph is that it supports states. So when I press key, you see that it's used this previous state. The state is encapsulated in data block, and when the program snake2 is evaluated here, the data is installed in data block like some custom structure and other types, and then in run I got the data and initialize if, for example, snake is intent, etc. And then I can add like I can duplicate snake, and I can have several games at the same time. Just control it. You see different snakes. Yeah, I can add another attribute here like boolean to animate snakes. To make it animatable, I need timer, because the graph is evaluated once something triggers it. Now only these widgets trigger it. A timer triggers it by timeout function. Timer. Now nothing is happening. I need some start. Yeah, it's very cool. Oh, here I need animate too. Oh, the first snake is already pushed the wall, and the game is finished. The game over. Yeah, you see, it works, and actually, it's interesting to add widgets. Here more complex, and maybe some viewport. I don't know how to do it, but it's cool to maybe control deformations to write my nodes here. Actually, I can create here some things like rigs or some processing. This is a standalone program, and it is not binded to my, it's a separate thing, but you can create some complex graphs which take some attributes, process attributes, where connections very cheap, and you can connect wherever you want, even large arrays. And then you have outputs. So you can export this as a separate JSON file for graph and write my node that accepts this graph using my compiler DLL file that can run C++ code and these modules. And you can make some mapping from my attribute from node to this graph attribute, like connecting my input attribute to this k or another attribute. And so with the output attributes, and you can change everything here, save, and in my everything updates. It's like Fabric Engine or something like this, but this is a separate tool, and I think it's maybe interesting not only for Maya, but because it's nice to experiment, to test things, and when I add complex types like vectors, matrices, arrays, maybe working with geometry and widgets, it's cool to see what's going on, to see um, what's going on in between connections. Here you see an A, it's not available, but you can implement your own types and how they're written here. And of course, I can implement how to print data block for each node and separate thing all in progress. But the idea, I think, is the same. Yeah. I hope you like it. Mhm.